Hello, welcome back. Uh, let's start with the next section, the section B of this specimen paper 2024. So here comes question number 4 for 10 mark students. Now, the best part in this specimen paper is highlighted that there are two complete sub questions which are based on light. That is question number 4 and question number 5. This should give you a simple hint that these two questions, which are completely dedicated to light, that means this chapter plays a very important role in your board exams. Let's try to figure out what is the question and let's try to find what would be the possible answer. So the question is, diagram given below shows a fish in the tank and its image is seen on the surface of the water. So this is the original fish and this is the image of the fish which is seen. The sub question is, name the phenomena responsible for the formation of this image. The phenomena of light which is responsible is total internal reflection. That's perfectly correct, students. The phenomena which is responsible is TIR, that is total internal reflection. There is one more sub question that's related to this question is, the question is complete the path of ray of light through a glass prism of critical angle 42 degree, very important, till it emerges out of the prism. So we have this prism here and there is a ray of light which is going to be incidented on that prism. To make the things much more easier, let's try to name that prism. Let's name this point as A, B and C. Now students, if you see at angle A, there is a 90-degree angle getting formed. At B, I have 45. So by default, this angle C should also be 45. So if I try to see, this becomes 45, 45, 90 prism, right? And students, if you see the ray which is going on the surface AB is also making an angle of 90 degree. So if I try to see this ray very carefully, I'll name this ray as ray P and Q. Now, since there is a ray of light which is going to move on that surface A, B, that ray is going to go with an angle of 90 degrees. So let's try to extend that ray ahead. We know that students, when the ray of light falls on any surface or hits any surface where it is going to go normally, it's not going to deviate anywhere. It traces the same to same path. So if I try to extend this ray till the surface BC, there is a point where this ray is going to intersect. The moment where it is going to intersect, students, we will call that point as normal. And at that point, we are going to draw a normal. Now, let's try to find out what could be the possible answer. Now, students, this is very interesting. If you see here very carefully, this is 45. This angle here is 90. So this angle will also become 45. So from 90, if this is 45, definitely yes, this angle should also become 45. Critical angle is 42. So students, as per the concept, angle of incidence, which is 45, that angle of incidence, if it is greater than critical angle, then there will be a concept of TIR. Don't forget. So this ray of light after hitting the surface is going to bounce back. And when it is going to bounce back, it is going to move back with the angle of 45 degree. The point where it touches the surface AC, there again it makes an angle of 90. That's perfectly correct. Now, this diagram which we have drawn is very important. There are total three diagrams which are based on prism. One is 45, 45, 90 prism. Next is 60, 60, 60 prism. That's equilateral prism. And the third one which we have is 30, 60, 90 prism. Every year in board exam, there is a question which is based on this for either 3 or for 4 marks. I hope this is clear to us, everyone. Things which you need to take care when you are going to draw the diagram. You need to see that you are making a note of each and every angle. Please don't forget to name the rays. This is P. You can name this thing as O. The ray which is emerging out, you can name it as R. Even don't forget to name the angles of the prism. So here we have named it as A, B, and C. I hope this is clear to us, everybody. Simple. Let us take the next question, students. The next question is again related to a chapter of light. The question is, refractive index is 1.33 at a certain temperature. What does that mean? Refractive index is 1.33 at a particular temperature. When the temperature of water is increased by 40 degrees, the refractive index changes to X. We need to figure it out, students, whether the value of that X is going to be small than 1.33 or is it going to be greater than 1.33. So technically here, students, they are trying to update us that what is the relation between temperature and the refractive index. Technically speaking, temperature, students, we know that it is inversely proportional to refractive index. So students, if temperature is increased, so here as per the question, the temperature is increased by 40 degrees Celsius, that means the refractive index should decrease, right? Because they both are inversely proportional. Am I correct? So originally, the refractive index which is given to me is 1.33. So don't you feel, students, if the temperature is increasing, that means refractive index should be less than 1.33. So answer for this sub question is the refractive index should be less than 1.33, and we can specify the reason as refractive index is inversely proportional to temperature. I hope this is clear to us, everybody. Simple. Perfect. Great. Sure. Let's take the next one. The next question which we do have is a sub question that's related to this part. The sub question is, state the difference between normal reflection and internal reflection. So sorry. So we need to find it out, students, a difference between reflection and TIR. So just a minute, I'll erase this whole part. Okay, sure. Let's find it out. I need 2 points here to specify the difference between them. So when I talk about reflection, normal reflection, this reflection can be possible, students, whenever you see any reflecting surface or when you see any shiny substance, right? You need a opaque and a shiny substance for reflection to be possible. When I talk about total internal reflection could be possible when ray of light is traveling from denser medium to rarer medium. Condition 1. Condition number 2, students, when angle of incidence is greater than critical angle. So you can write this as your point number 1. Reflection में point 1, you need a shiny substance for reflection to be possible. And here the ray of light should travel from denser to rarer and its angle should be greater than critical angle. Students, in reflection, you know what happens? In reflection, a part of light is reflected and some part of light is also refracted, students. Here, in normal reflection, there is never 100% reflection. Some rays are again going to enter back into the same medium, right? So I can technically say that, just an example, if there is 100% of light going to fall on any mirror, from that 100%, 90% rays will turn back and 10% of the light will be absorbed. But the best part of TIR is reflection which is going to be seen will be complete 100%. If there are 100 rays, just an example, if there are 100 rays which are going to fall on any surface which is traveling from denser medium to rarer medium, and if its angle is greater than critical angle, students, all the rays are going to bounce back. There is no loss of energy in TIR, but in reflection, there is some loss of energy. These are some major points which we can write it when we are going to present our answer in the exam. Let us take the third question, students. So again, a third question. It's an application-based question of light. They have given us a rectangular glass block, and there are certain rays which are trying to enter and few rays which are trying to emerge out. So if you notice here very carefully, this is the observer, right? And here I have the object which is placed. There are some denotions which are updated here. First, Y. Y indicates the thickness of the glass block. Then I do have X here. X indicates the shift between the original ray and the refracted ray. Okay. The question is, above diagram shows that an observer sees the image of an object O at I. Okay. We need to name and define the phenomena responsible for seeing the image at different position. The image which is going to be obtained, that image will be obtained at different position. So which phenomena is responsible? The phenomena responsible is refraction of light. You know why refraction of light? Reason is very simple. First reason, there is a glass block who's going to act like a transparent medium surrounded by air, who's again going to act like a transparent medium. So when the ray of light passes from one transparent medium to another transparent medium, there is a change in its path. And when the ray of light changes its path, there will be a change in the position of the image. Are we able to understand? So this is the answer. Next question. State the effect on X when Y increases. X means shift. What will happen to the distance between two lines? What will happen between the distance? So students, this shift which we do have here, it depends upon two simple reasons. First, the thickness of the glass block. Second, by what angle is the ray going to be incidented? Make sense? So here, there is first factor who is taking part, that is thickness. They have told, state the effect on X, means state the effect on shift if Y increases. That means if thickness increases. Technically, students, shift is directly proportional to the thickness of the glass. So if the thickness increases, the shift will also increase. Similar way, the second sub question is, what will happen to the shift if Y decreases? Can I simply again say, students, shift will decrease because it is directly proportional to thickness. Is it simple for us to understand? So this was your complete question number 4, which is of 10 marks. Let us take the next question, students. Question number 5, again for 10 marks. You have 3 sub questions, 3, 3, 4. This is a numerical which is from your chapter number 5, refraction of light through lenses. Let's go with the question. The question says, an object is placed at a distance of 24 centimeter. Point number 1 to be noted. Object distance, which is denoted by U, is 24 centimeter. And we all know that object distance is always going to be negative. So this becomes minus 24 centimeter. This object is kept in front of a convex lens. So here we do have a convex lens. The focal length of that convex lens is 8 centimeter. So we have over here focal length as 8 centimeter. We need to find out what will be the nature of the image. For finding out nature of image, I need to actually find out what is the position of the image. So on the dependence of position of image, we would be able to conclude what is the nature of that image. Let's try to find it out. We'll use a formula called lens formula, students. I hope we all know what is lens formula. Lens formula is 1 upon V minus 1 upon U is equal to 1 upon F. So technically, when I try to use it, I'll shift this thing on the opposite side, which gives me 1 upon V is equal to 1 upon F plus 1 upon U. The values which are given to us, they are F, which is 8, and U, which is minus 24. I shift that negative sign in the numerator, which gives me 1 upon 8 minus 1 upon 24. Since we know that the denominators are not same, we'll have to take LCM. So LCM is 24, 8 into 3, and this will become 1. So students, we will get 1 upon V is equal to 2 upon 24, technically, which gives me V value as 12 centimeters. Now, if you note one thing very carefully, image distance which I have found out here is positive. That means this is which type of image? This is a real image. And students, if image is real, then it should be inverted. We know that very well. Calculate the distance of the image from the lens. That is simply found out. We even have to conclude the entire nature. When I'm talking about nature, we also have to find it out. What is the size of that image? That could be simply found by using magnification formula, which is m is equal to v upon u. Students, we know that v is 12 and u is minus 24. I'm getting the answer as minus 0.5. This 0.5, since it is less than 1, that means the image is diminished. So the nature of the image is real, inverted, and diminished. And image is formed at a distance of 12 centimeter the lens. Was it simple? Was it easy for us to understand? So this was your entire question for 3 marks. Let us take the next question, students. The next question is, when a sunlight passes through water droplet in the atmosphere, it gets dispersed into its component colors, forming a rainbow. Now here, water droplet which we have, students, we know that they are going to act like a prism. Sunlight is a pure form of light which is white in color. So as per the concept, we have learned that when a white light is going to be passed through a prism, like when a white light is going to fall on the prism, that white color, which is called as polychromatic light, which is made up of 7 colors, they will split up, right? So on the basis of that, there is a question which is given to us. The question is, when this white light passes through the prism, which color will show the maximum angle of deviation? That's your first question. And which color shows the minimum angle of deviation? Come on, we know it very well. If I have a prism here, and if there is white light going to be passing through the prism, white light gets divided into 7 component colors, which will be in the sequence of Vibgyor. Violet will be at the bottom, red will be at the top. Maximum angle of deviation, students, is going to be for violet light. Am I correct? And when I'm talking about the color which has, and the color, students, which has a minimum deviation, that color which has a minimum deviation is going to be red color. So the color which bends the least is red. The color which bends the most is the violet. That's your sub question 1. Second question is, instead of sunlight, if a green colored ray is going to be passing through a glass prism, what will be the color of light when the ray is going to emerge out? So sunlight is replaced by green color light. Now tell me one thing, if sunlight is replaced by green light, what will be my color emerging out? I need to fix it. Very simple. Sunlight which is polychromatic. When I'm talking about green color is a monochromatic light, right? Prism is used to split the light. Prism is never used to change the color of the light. So since green color is incidented, the ray which is going to emerge out will also be green in color. Understand one thing? Prism is used to split the light, not to change the color or not to change the wavelength. Are we understanding? Simple, easy. That's your question number 2. Let us try to move to the next question. That's question number So here comes the next question, students. The question is mixture of red, blue and green. So there are three colors, red color, blue and green, who are going to be passed through a convex lens. Convex lens is a converging lens. State whether the rays will be passing through a single point or they will be at a different points on the principal axis after refraction. It's very simple. I have three colors over here, red, blue and green. When these colors are going to go and hit the convex lens, we know that there will be refraction of light. And because of refraction of light, students, can I say that each of them, that is red, blue and green, will go at different points on the principal axis? Technically, the color who's going to deviate the most, let's try to find it out. Which color is going to deviate the most? So V, I, D, G, Y, O, R. The color which is going to deviate the most will be blue. So first I will be having blue color, then we will be having green, and then technically we will be having red on that principal axis. So here I do have blue followed by green followed by next question. Name the invisible radiation which can be obtained by quartz prism. The radiation which could be easily obtained by quartz is ultraviolet radiation. Point to remember. Ultraviolet radiation could be obtained by quartz prism. Name one radiation having wavelength longer than the wavelength of ultraviolet. It is infrared. The one whose wavelength is greater than ultraviolet is infrared. So this was your question number 5. Again for 10 marks. So you must have seen, students, we had two different questions, pure questions, which were completely based on light. Thank you so much for watching this video. Bye. Take care. Have a nice and amazing day.